Hello everyone, welcome back to the channel. Today, finally, we are diving into how to integrate MCP with the large language models. In the previous video, we looked through how to connect existing MCP server like Tably. In this video, I will show you two things. First one is how to connect MCP to an LLM, and second, what security risks you need to keep in mind. So let's jump in. First, we've already set up various MCP servers like file system, Git, and Tably. So now all that's left is to connect them to the LLM. To make it clearer how to call functions with the LLM, I will insert the context showing which tools exist and how to use them. This way, the LLM's context window will be filled with the tool descriptions, required arguments, and usage instructions. While we could just use the LLM with the integrated MCP tools, it's more interesting to turn this into a chatbot app. Let's take a look at how our app works. I already made a chatbot application in my Git repository, which is MCP tutorials. So you can just clone it by copy and paste git clone like this. Then first of all, to execute the chatbot application, you have to specify OpenAI API key. For executing this chatbot application, you have to pay money for OpenAI API. You can go OpenAI API website. This is the OpenAI API, and you can go to there and log in API platform. You have to create a new secret key, which is the API key, and then copy your API key and insert this .env file. And also you have to specify your Tablet API key, which is free up to 1,000 requests. And if you finish writing your API key in .env file, then the next thing is install the libraries. All you have to do is first create the virtual environment. You can create a 3.11 Python version, and with specifying this command uvsync, you can match the library version in this uv.lock or py project. Actually, the Python requires 3.13, so it's better to use Python 0.13 version. I think it would be not a problem in my project. And you can run your chatbot application by run agent chatbot.py, and let's see. Alright, it connects to the multiple MCP server, and you can type in this terminal anything like ChatGPT. I'll ask the chatbot application the big number multiplication. Multiply this. Is very difficult. The assistant with answers is very large. Let me perform the calculation for you. So it seems it prepares to calling. So okay, do it. Then yeah, the executing to multiply, and the final response is this. And let's check whether the correct or not. Python, and where is my question? The multiplication. Oh, is my question, and copy and paste. Then the answer is same. Yes, the answer is correct, right? Alright. Then we also connected to our Tably MCP server, so it has the search engine ability what is the top 3 AI company in 2025. Let's see. Actually, it doesn't use the search engine, so the result looks reasonable, but let's make it use our tablet tool. Use a tool, then LLM generates the tool calling, and tablet search is executed. Then the result is a little bit different from what it had before. Number 1 is OpenAI, second XAI, and third is CoreWeave. It's alright. So in this way, we can communicate with the LLM with the tools. So we can know how our application works. So let's go deep inside by doing debugging. Right, so step into first one, load .env from our .env file, this one, and server config path is this one, server underbar config.json. This is the configuration for our MCP server, so you can check the MCP server is defined in this value, and there is a file system, tably, git, and calculator, which is our calculator functions, and it opens the server config.json and loads as a dictionary for using it, and it instantiates the server class in the list. We can go to div inside the self.name and its name, and configuration and stdio context or session or other things like that. We can see this is loading just this file system, name equals file system, and config is command npx, and this one argument. Alright, and the other one is just the default, and we iterate through other MCP servers, so in this case the tably, and the next one is git, and the last one is calculator, and fetch the OpenAI API key, and we instantiate the LLM client, which is just a wrapper of the OpenAI API. Get OpenAI through OpenAI API key. Alright, so, and then we instantiate the chat session. This is the basically where our chat executed, and there is servers which we already defined. And this is a server through server underbar config.json, and the LLM client is OpenAI API, and start. And this is basically initialize our MCP server. Actually, we didn't initialize the server yet. It's basically what we saw in the stdio client, like this one. SDO server parameters. We define server parameters, and with the context manager, we initialize our sessions. So it's basically similar structure. And the different thing is we use the context manager with this with keyword, but in this case we don't use context manager. We just specify the manually. Alright, so in this way, all the server initialized tools will be inserted in this list or tools list. We can jump in. Alright, then server using list tools method or tools will be inserted in this results. Let's check all tools. This is the, so you can see this is git diff or other things, And let's check one. Let's check the one, and the format for LLM method is defined like this. It's basically return the string, and it contains the input schema or description and which arguments are required, and also the tool name. So the result is like this: tool name and arguments. In this way, LLM can know which tool exists and which tool arguments are needed for calling tool. And after that, we define the system message. The system message is like this: your helpful assistant with access to these tools. And the tool's description is the variable will be inserted into this here, and choose the appropriate tool based on the user's question. If no tool is needed, reply directly. Important one is when you need to use tool, you must only respond with the exact JSON object format below, nothing else. If the LLM think the tool is needed for responding the question, then we'll generate this kind of a format. And then after receiving a tool's response, first transform the low data into a natural conversational response, and second, keep responses concise but informative. Third, focus on the most relevant information, and fourth, use appropriate context from the user's question, and fifth, avoid simply repeating the low data. And please use only tools that are explicitly defined above. So the LLM can't call the tool which isn't explicitly defined in this tool's description. So let's check tool's description, and then it contains all the tools about tool name and tool description and which arguments are needed in this string, so LLM can know about all the tools. And basically in the infinite while loop, user will type in the question, and if the user input is hit or exit, then it will break out in the while loop. If not, the message will be appended, and LLM, which is OpenAI chat model, will send a request using this data, and then LLM will respond about it. Let's try this. Then we have to type. Let's do this big multiplication, and it checks whether hit or exit, the message is appended and get response. And I just use GPT-4o, and the response will be fetched. We checked the response, right? This is the result. This is the result of AIs. And we can process it. Assistant result is like this we saw before, and we process this LLM response. Actually, this is the important concept in tool calling. LLM response, let's check this out, which is the answer of AI, and we load this through JSON. And because this data couldn't be loaded as a dictionary, it lays the exact JSON decode error, and it just returns the original LLM response, which is this one. Then it appends the assistant response to the messages, then we have to type another questions or message. I have to type the message, and the LLM says the result is a very large number, so I just type use the tool. Then let's see what happened. The message is also appended, and a LLM will respond about my answer. And let's check LLM response. And interestingly, the LLM response this dictionary type string, you can see there is a tool name and argument. Argument A is this number and B is this number. Alright, then we produce this LLM response and we try load this LLM response using JSON library. It actually now load the dictionary using JSON library, so we can call. We can check this. We can check the type, and it is the dictionary. And check if this dictionary contains tool and also contains argument key, then it will execute tool through iterating or tools. The processing logic check if any tool name is equal in the list tool list, then it try execute tool with the tool name and argument. Execute attempt. Actually, it is just use the core tool method as we saw before, and the results will be returned if it is a success, and the result is this one. Result, this one, and we can see the result is integer value. And result, and return this tool execution result. If result is not a LLM response, which means it is a tool's execution result, then messages is appended into messages list with the tool execution result. And another request by including tool execution result. Then let's see what happened. Then final response is, it says the product of multiplying is this one. So basically LLM responds the user's question with tool's execution result. So we hope this result is correct. And again, go to infinite while loop, and we can type in another question like this one. And this way we can communicate with the LLM utilizing the tool. Our exit. So this is how the LLM can call a tool and incorporate each result into the conversation. Now we understand how the app works under the hood, but writing all this code manually can be tedious and error-prone. The good news is you don't have to. There are libraries that help simplify tool calling agents. Some popular options include LangGraph and Llama Index. Let me briefly introduce LangGraph. LangGraph lets you build the same kind of application with much less boilerplate. It makes it easy to instantiate MCP servers, interact with humans, and call tools. A nice bonus is that you can easily swap AI models. For example, switching from GPT to Cloud without rewriting your logic. Tool calling is also more stable. Let's check this out in the LangChain or LangGraph version. You can see the code is slightly shorter than the previous one. We can see the difference. The left one is the LangChain version, and the right one is use the OpenAI API version. The last line is T3 in LangChain, and the OpenAI version is 48 lines. So it is much simpler and shorter, but the core logic is very similar. You can learn this code, and actually it is more stable using tools. We can execute using UB-learn agent, LangChain agent. It also connects to the MCP server, Tablet MCP, and file system. We can ask similar question. What is this? What we did before, we type like use the tool enhance for calling the tool, but LangChain version more stable, so we call the tool if the question the LLM think the core tooling is needed, then automatically it calls the tool and gets the result. So you can see there is a core tool request. LLM use the tool result for asking your question. Okay, so let's check again whether it's correct or not. And the result is correct. You can see it. Alright, and ask about another question. What is top 3 AI company in 2025? We also call the Tablet MCP server, and it fetches, and the answer is similar like we did before using OpenAI version. And if you want to change the model, then all you have to do is just fetching the API key and rename this model name. So it's simpler than using this OpenAI API key. Now, before you go wide connecting random MCP servers, we need to talk about security. The most important principle is only connect to MCP servers you trust. As you know, LLMs and AI systems are increasingly vulnerable to security risks because they tend to follow natural language instructions too literally. Imagine you come across a really interesting MCP server and you want to connect it to your application. The danger is that the MCP server itself could be dangerous. Let me give you 2 examples. First one is prompt injection via tool descriptions. As you already saw, the tool description is inserted into the system prompt for LLM to know about the tools. But in this way, prompt injection can happen even though LLM don't use the specific tool yet. Second, mismatch the tool behavior. Another risk is when the tool description doesn't match the actual internal logic of the MCP tool. Remember, the LLM only sees the description we provide in the system prompt, so it has no way to verify whether the tool actually does what it claims. That means a malicious or poorly designed tool could mislead the LLM. For example, imagine a tool descript as a safely format text into JSON. The LLM will happily trust and call it for data formatting, but internally the tool could be doing something completely different, like writing files to disk, exfiltrating data, or even deleting content. In this case, the LLM think it's just calling a harmless formatting tool, but behind the scenes, the tool is exfiltrating data. I will show you the mismatched tool behavior example for you to understand better. This is the calculator functions we defined before, and there are 4 arithmetic functions, add, subtract, and below there is also another multiply function. It is named multiply, but actually it did subtraction. And the description means multiply 2 integers together. So LLM thinks this tool is just do the multiplication, but it actually didn't. And for checking the internal logic is different, I inserted the log message warning to behavior mismatch. This tool is different from what you might expect. And for testing this mismatch behavior, we have to comment out the normal multiply function, and we again test our LangChain agent. First of all, we have to exit and you belong agent LangChain agent.py. Let's test about the multiplication. What is this multiplication? Then let's see. It calls the tool of multiplication, and so we can see our log message. We inserted a warning to behavior mismatch. This tool is different from what you might expect. So the product is this. So LLM don't know the internal logic of the MCP tool. So in this way, the attacker can do the malicious effect. And also, let's check whether the result is correct or not. The result would be different, is not correct, because the tool is misbehaved. 86, 48.2, but this is 45.3. So the result is also incorrect. We can know LLM called the mismatched tool. There can be even more dangerous scenarios when working with MCP servers, and the reality is, no matter how carefully MCP server developers try to avoid the security issues, attackers can often find creativity tools to reach sensitive resources inside your application. It is worth noting that MCP security isn't just a technical detail, it's a growing research area. Alright, let's recap what we learned. Today we looked at how to connect MCP to an LLM and how the integration works under the hood, and the security pitfalls you need to watch for. Thanks for watching this video. I hope we'll see you again soon. Goodbye.